Right, and the general science activity for today is forces and movement, and we are going to concentrate on push and pull. We will also demonstrate how to make a force meter. Now, if you look at this picture, it's a picture of two teams, the yellow team and the red team, and they are playing a tug of war. Now they are both pulling towards each other. But when we push away from our bodies. Now, the only reason why they are not falling over is that they are doing the pulling and pushing at the same time. Their hands are pulling the rope, but the feet pushes so that they are able to pull the rope, but they are pushing against the ground so that they do not fall over. Now, there are many things that we push and pull every day. Even the simple action of opening a door is some of the doors you need to pull towards you to open, some of them you need to push away from you to open them. Now, push and pull both have force because if there's no strength in your pulling, that door won't open, and if you don't use strength to push at the door, it will also not open. And like I explained yesterday with the bat connecting to the ball, that sometimes that force can change direction. And it's exactly the same here, where the children are kicking and throwing and catching a ball. When you throw the ball, you are pushing it away from you, but when you are catching it, you are pulling it towards you. Now, sometimes when the ball is kicked towards you, you can kick it away from you in another direction. Now, that force makes the ball to change direction. Now, let's have a look at this biggest tug of war that has ever taken place in the world. Now, this happened in Okinawa in Japan, and it involved thousands and thousands of people where they used a rope which was 2 meters thick. Now, most of you are already a meter. Now you need to add another meter to your height to imagine how thick that rope was and the kind of strength needed to pull it, and that the people needed to push against the ground for that amount of force to have this tug of war. Now, your worksheet is called Pushes and Pull. And in this picture, there is somebody pushing somebody on a swing. There is somebody throwing a ball. There is somebody pulling a cart with a doll in it. There is a child sliding down a slide. Then we have a boy kicking a ball and two boys on a seesaw, not on a slide, sorry. So now the one going down needs to push down, and the one is being lifted up. And then we have two boys fighting over a toy, and they are both pulling. Now it says, label all the pushes and pulls you can see in the picture and draw an arrow to show the direction of each force. Let's start with the swing. Now, where is my pencil? Okay, let me just use a colored pencil. On the swing, the lady here is pushing. So we can write here on top of it, it's a push. And the direction of the force is going that way. Is that not so? So there's my arrow for that push. And here, he is also pushing the ball away from him. Again, you write push. But he's pushing, the force is going that way. And you draw your arrow. Now let's look at this girl. Is she pushing or is she pulling? She is pulling. So we write here pull. And the direction of that force is towards her. She's pulling her towards, and you can see here the push is away from her. Now, I'm going to let you decide whether this is a push or pull. What's happening here? Push or pull. And there's both sides. Now, because both of these boys are doing a force, something that is force. So you need 2 arrows here. And then there's a little girl sliding down the slide. Is she pulling or is she pushing her body down that slide? So you need to be very careful. Here you also need to tell me if the boy is pushing the ball or he is pulling the ball. And that is the one activity. Now we go on to the next activity, where you are going to need an elastic band and your ruler. Now, your ruler, you need to hold the 0 point at your fingers, and the 30 needs to be at the bottom. This will indicate the measure of how much force is the object that you are measuring with the elastic. Now it says you will need an elastic band to make your own force meter. You will attach different objects to the elastic band. Now this will allow you to measure the force needed to lift each object. The longer the elastic band stretches, the bigger the force. And the less it stretches, the less the force. Now, here you are going to have, maybe you can ask your mom or your dad. Let's see, you're going to need to be able to put things on your elastic in the middle to see the weight, the measure of that force. And you can do 3 things. Here we've gotten a little toy car that was put on the elastic. You can perhaps even take your washing rag, put it in the plastic and elastic and lift it up, or anything that can go over the elastic. Now you write that object there. Now let's look at this car. You write toy car, perhaps, which is what you will, toy car. You write it there, and here you will need to record. I'm now going to estimate that looks like 20. So I write here 20. But 20 what? What do we measure force in? Force is measured in newtons. So we need to write here 20 newtons. Now you can perhaps put an eraser. And then you write eraser there. And depending on the size of the eraser, I think it will be about 10 to 15 Newton. So you can write here 12 Newton. But you are going to have to measure against your ruler to see where the eraser stops. And that's what you record. And then you do an extra object that you put on your eraser. And remember, the longer the eraser stretches, the greater the force. The less of a stretch that happens, the less the force. And that is the general science activity for Thursday.